The age of oil is drawing to a close, and that raises a massive question. Who's going to dominate the next era of energy? For centuries, global power was all about who controlled the energy. Think Britain's coal or America's oil. Well, today, we're diving into the new great game.
I want you to picture something. A huge, sprawling steel mill. But instead of those thick, black plumes of smoke pouring out of its stacks, it's just quietly exhaling clouds of pure white water vapor. That's it.
Now, that image, that's not some sci-fi fantasy. It's the very real endgame of what's projected to be a $2.5 trillion global energy takeover. This isn't just another green alternative. We're talking about a complete rewrite of who holds power on the world stage. And it turns out one country has been quietly, methodically getting ready to corner the entire market.
So, why this sudden mad dash for hydrogen, and why, of all places, South Korea? Well, for them, it really comes down to survival. This is a nation without a single drop of its own oil, making it almost completely dependent on imports. And that kind of economic vulnerability has fueled, for decades, a national obsession, engineering a future where they finally control their own energy destiny. See, the big problem with renewables, their Achilles heel, has always been reliability. The sun doesn't shine at night, the wind doesn't always blow, right? But hydrogen solves this. It acts like a gigantic energy battery, storing all that excess power from solar and wind and creating this huge, stable reservoir that we can tap into 24/7.
And South Korea's lead in this space is absolutely no accident. While most other nations were just starting to talk about it, they began the foundational research and development way back in the 1970s. Then, in 2020, they put it all into high gear, passing the world's very first Hydrogen Act. This was a national framework that was literally decades in the making.
Okay, so how do they actually build this A to Z ecosystem? Well, it all starts at the beginning, with A, clean production. The first massive challenge was just figuring out how to make hydrogen cleanly, safely, and most importantly, efficiently.
Here's the thing about renewable energy. It's volatile. It comes in surges. So how do you tame an electrical storm like that? If you just pump those erratic power surges from, say, a wind farm directly into a standard electrolysis machine, the thing that splits water into hydrogen and oxygen, it's a recipe for disaster. You're looking at mechanical failure, or even worse, a catastrophic explosion.
Well, South Korean engineers at the Korea Institute of Energy Research, or KIR, they developed a load-responsive system. The secret sauce is a unique separator membrane that does one job perfectly. It keeps the explosive hydrogen and oxygen gases from ever mixing, even when the power input is jumping all over the place. It basically turns that chaos into a safe, continuous flow of green hydrogen.
But safety is only half the battle. To bring the cost down, researchers at another institute, KIST, did something brilliant. They abandoned liquid water altogether. By using superheated steam, we're talking between 600 and 800 degrees Celsius, the thermal energy does most of the heavy lifting. The extreme heat makes the water molecules vibrate so violently that electricity only needs to give them a tiny final nudge to split them apart. It's the most efficient way to make green hydrogen on the planet.
Okay, so you've made cheap, clean hydrogen. Fantastic. But now, what do you do with it? In our A to Z ecosystem, that brings us to M, for movement. How on earth do you transport this incredibly volatile gas across an entire ocean?
It's a logistical nightmare. To turn hydrogen into a liquid so you can ship it, you have to cool it to minus 253 degrees Celsius. Let me just say that again. Minus 253. That's basically the temperature of deep space. The cost to build a global fleet of those kinds of cryogenic ships is just astronomical.
So, Korean scientists took a totally different approach. Instead of fighting that insane cold, they figured out how to just bypass it entirely with a three-pronged room temperature arsenal. First up, ammonia. You basically attach nitrogen to hydrogen and you get a compound that's way easier to transport. The real trick, though, is getting the hydrogen back out efficiently at the other end. KIR developed a brand new metallic catalyst. That's the stuff that speeds up the reaction. And it's twice as efficient while using just 1/10 of the material of the old ceramic methods. It's a massive, massive cost saver. Next is something called LOHC, liquid organic hydrogen carriers, and this is just elegant. It's a special oil that literally dissolves hydrogen gas, turning it into a stable liquid that behaves just like crude oil. And you know what that means? You can use the existing global fleet of oil tankers and pipelines. You're recycling the infrastructure of the fossil fuel era to carry the fuel of the future. And finally, we have the endgame, solid-state storage.
The best way to think about this is like a molecular parking garage. Individual hydrogen atoms are literally parked inside the atomic structure of a special metal alloy. It's incredibly dense, it's perfectly stable, and it completely eliminates any risk of explosion.
So, we've solved production with A, we've solved movement with M. That brings us to the end of the line, Z for utilization. This is where all that hydrogen actually gets used, and it has the power to totally rewrite the map of global industry, starting with steel. This is what we call the steel paradox. It's the absolute backbone of modern civilization, but it's also the single largest industrial source of greenhouse gases on the planet. Why? Because to make steel, you have to burn mountains and mountains of coal. And with global carbon taxes on the rise, that traditional method has essentially been handed a death sentence.
The solution, believe it or not, comes down to really simple chemistry. Traditional steelmaking combines iron ore with coal, and the byproduct you can't avoid is CO2. But with South Korea's HyREX technology, you just replace the coal with hydrogen. And what's the only byproduct now? H2O, pure water.
The engineering behind this is just incredible. It's called a fluidized bed reactor. Instead of just letting the iron ore sit there in a big pile, powerful jets of hydrogen are blasted up from below. This causes the heavy ore particles to literally dance in midair, like a fluid, which ensures every single particle reacts perfectly with the hydrogen.
So when you step back and you put all of these pieces together, the production, the movement, the utilization, the A to Z, a completely new picture of global power really starts to emerge.
From A to Z, from production to transport to end use, South Korea has engineered a completely sovereign end-to-end technological blueprint for the entire hydrogen economy. Right now, they are the only nation on Earth that has mastered every single step of the process. For the last century or so, power was basically a geographic lottery. If your nation happened to be sitting on oil, you held all the leverage. And South Korea, with no natural reserves of its own, was always at a disadvantage, always forced to be dependent on others.
But that entire reality is being flipped on its head. And it leaves us with this final thought. In the 21st century, is power something you find buried deep underground? Or is it something you engineer in a lab? We might just be witnessing the very definition of a resource-rich nation being rewritten right before our eyes.